Welcome to this series of videos about while loops. Now, there's a lot of detail on while loops, a lot more than people would really consider, and it's the first time where people truly get stuck with programming. So up to the point that they hit loops, things have probably been going quite easy because it's quite sequential. As soon as we start putting a loop in there, we have to start to think about repetition a bit more. It becomes a bit more difficult, and the problem is a lot of the material on the internet that you actually go through, they kind of skim over loops quite quickly. You know, they'll say what it is, they say how it works, and then assume you understand how to use it. I find that is not the case with a lot of students. They truly get stuck with while loops, and this is the one part that if a student's going to skip part of a question, it's the repetition part that they're going to try and skip. So I'm going to try and break this down as much as I can do, and hopefully give you all the tools and all the information you need to be able to solve problems using loops. So let's go. Now, loops, like if statements, will make use of these conditions. So I've just put this slide back up to remind you what they are. It's very important you get used to these symbols because they crop up in programming all the time. You will never be able to escape from them. So greater than, less than. The key thing is remember which way around they go. So less than points to the left, greater than points to the right. So just remember that, and to be honest with you, you won't go too far wrong. The other thing that people mix up, and I've already kind of alluded to it a lot, is the double equals. So when you're trying to compare two things together, it's either they are the same, use two equal signs rather than a single one, because a single one, remember, is assignment. Anyway, so let's consider a flowchart when we start to think about loops, and this kind of will give us the kind of indication of what we truly mean by loop. So on the face of it, looping is where we will return to an earlier part of an algorithm. So in a flowchart, what we have is our normal flow. So it's going from top to bottom as per normal. So we're following the flow, following the arrows up until we get a decision. Now before, when we're using decisions in a flowchart, we just simply will go one way or another. Okay, and the same thing is going to happen here, but this time we actually are going back to an earlier part of the flowchart or the algorithm. Now that is the key behind looping. So it's where we will have some form of test, some form of condition written in the way that we're used to, so greater than, less than, equal, that kind of thing, and it will basically repeat part of a code, i.e. return to the start of a block of code and run it again. Okay, so here I'm repeating the same command. So I'm doing this one, then this one, then I'm going to here, doing a test, and then coming back. So it'll print out 0 first, add 1 to x, so x becomes 1, 1 is less than 10, it repeats, it will come back to this part here, prints out the 1, adds 1 to it, test it again, and we'll keep going until x is no longer greater than 10. As soon as that condition is no longer true, it will then go to the stop and end the program. So in order to kind of get your head around how to code a while loop, the first thing to realize is that we need a variable. Okay, a variable is absolutely crucial for loops because what it allows us to do is keep track of where we are on the loop. Okay, without a variable in this flowchart, there's no way we'll be able to know whether we should keep going or to stop. Okay, and the same will happen inside a program. So in this case, I've got a variable x. And I've written this a bit more codey now. I'll just put x equals 0, so x has the value 0 assigned to it. And I can do that then, do that through the rest of this code. But it is really important that we have some form of variable which keeps track of where we are in the loop. So what I've done now is I've tweaked this flowchart ever so slightly, and instead of having more English kind of words in my flowchart, I've changed it into code. So I've got my print x, and that's the same as saying I display the value of x, so just print x, nice and easy. Adding 1 to x, I've changed it with this little bit of a code pattern. If you've never seen this code pattern before, let me just explain it. Essentially, it's going to take the current value of x, add 1 to it, and then assign the value back to x. Okay, so essentially adding 1 to x. Okay, so this code pattern is very common. For those of you who are a bit more familiar with Python or have seen other tutorials, you might see this instead. So x plus equals 1, and those two things are exactly the same. I'm not going to use this yet, not until later tutorials, because I want you to realize what it's actually doing and get used to this, because it is important. So taking the current value variable, adding a value to it, then reassigning it back to the same variable, it's a very common thing to do in programming, so it's important to get used to it. Here I've got some code which will print out values of x. Every time it prints out x, it's going to add 1 to x. So you can see here I start off with x being 0, I print it out, I add 1 to x, so x becomes 1. It then prints x out again, adds 1 again, and so on and so forth. So if I run this code, you can see it prints out the numbers 0 to 5. Now this is a very inefficient way of doing it, because you can see that I am effectively repeating the same code over and over again. So here, lines 2 and 3, you see they're repeated here, and here, and here, and you get the idea. So we can replace this with a while loop. While loops are the way in Python where we can repeat code. So let's get rid of all of that, and I'm going to start off with the while loop. So while x is less than or equal to 5, and then I'm going to indent in all the code that I want to repeat. Let's run this code, and you can see I'll get the exact same output. So let's delve into this code in a bit more detail. So in order for while loop to work, we must always have a variable. Now this variable has two purposes. First of all, it's what's used to keep track of when this loop should stop. Okay, because if I did not have a variable to keep track of when this loop should stop, the loop will go on forever, which wouldn't be good. To show you that idea, what I'm going to do is I'm going to take out this line of code here. Now, what's going to happen when I run this code? It will just keep going on forever. So let's actually run it, and you can see here I get lots of zeros, lots of zeros, and I'm going to stop it now because you can see it's just going on forever. So what's happened? Well, x starts off as 0, and then I've got this test. Now the code will repeat when this test is true. So x is less than or equal to 5. Well, 0 is definitely less than or equal to 5, so I print out x, but because x doesn't change, it repeats the whole thing again. So it jumps back up to line 2, runs this line again, repeats, runs it again, repeats, goes on for infinity. So I put that back in and I run it again, and you can see I now get a more suitable value. So long and short of it, we must always have a variable which we can use to keep track of when this loop should stop. Now the next part of this is when the loop ends. Okay, so this condition is controlling when the loop should end. So how often or how many times should a loop go? Finally, we've got the part of the loop which is actually making it go to the end. So how that variable is changing. And as I already showed, without that variable being changed, we would get an infinite loop. So that's our first look at as a while loop. The next thing we'll look at is how we can start to change these values to get different outputs. So let's get into the anatomy of a while loop now. So we are generally going to start off with the most simple type of loop, which is known as a counter-controlled loop. More on that later. So the most important thing is I must have a variable. Okay, it's without shadow of doubt I must have this variable, otherwise I cannot code a loop properly. Okay, so I have this starting point variable. Okay, Now I know I'm using X a lot. It doesn't matter what name you give this variable. It could be anything, it could be Y, Z, counter, it doesn't matter. Okay, I'm just using X for consistency for now. Anyway, this is the starting point. So we need a starting value for the variable. Okay, so this is kind of the start of a pattern of numbers, if you think of it that way. So we have a variable which we create. We give this variable a starting point, and that always goes just before the start of a loop. Okay, so that is really, really important. The next thing we need is a way to end the loop, and this is essentially the control of it. Now, this will always appear after the command while, and it's always conditioned in the exact same way that we see in if statement. So in an if statement, we would see something very similar. We'd have X maybe is less than or equal to 5. It looks exactly the same, apart from my bad mouse writing. So that condition there looks exactly the same as it would appear in a while loop. So we have the same tools for if statements and while loops. Okay, essentially they are exactly the same. The key difference here though is that this code inside it will only run when this condition is true. So when that condition is true, the code runs. If it's not true, what happens is it simply jumps to the end of the loop. Then we have the code that needs repeating. Now there's one piece of code here which I'll come on to in a second, which must always be there, and this is what I call the increment, but essentially the thing that changes my variable to make sure that eventually I'll end. And then we'll have the work we want to do. So in this case, I want to take the value of X and times it by 5, essentially giving me the 5 times table. So X 1 times 5 is going to be 5. I add 1 to X becomes 2. 2 times 5 is 10, and so forth. So this is the code that's repeated, and we know what codes be repeated in Python because of this indentation. Okay, so any code that's indented inside the while loop here is the code that will repeat each time this condition is true. So the final part of an if statement, which is absolutely crucial, is I need a way to make the condition false. Okay, so at some point as this loop runs and the variable changes, that variable must eventually make this test false. If it doesn't, what happens is we'll get an infinite loop and the code will just run on forever. Now this can be experienced quite easily, and it's a common source of bugs, and your program will probably stop responding, or you might get a massive wall of text suddenly appearing, or whatever happens to be. So it's important that we always have that way of changing the variable so eventually it will end. Let's explore the code we've just seen. I'm going to step through this code line by line so you can see how this code works. So we have a variable X, which is what we're using to keep track of how often this loop needs to run. So that variable starts off with a value of 1. Okay, so down here you can see that X has a value of 1. The while loop will basically repeat whatever's inside the loop when this condition is true. So X is currently the value of 1, and that is less than or equal to 5. So that means the code is going to run. So let's see it. It's now going to print X times 5. Well, X is 1, so 1 times 5 is obviously 5. And then it's going to add 1 to X. So you notice that X is now changed. Now, as soon as it gets to the bottom of the loop, it always jumps back to the top again and does the test once more. So the test here is 2 less than or equal to 5, which is obviously true. So it's going to run the code again. So it prints out the value of 10, then it's going to add 1 to X, and it's now going to run again. So it's going to continue doing this as long as X is less than or equal to 5. So it's 4 at the moment, so it's going to repeat. It's 5. Well, 5 is equal to 5, so it is going to loop one more time. So it's going to loop again. Now when it gets to here, okay, X is 6. Well, 6 is no longer less than or equal to 5, so the code no longer repeats. So this is how while loops work. Okay, so it will have a starting point. It will have the thing it's going to repeat. It's going to have something which will make it get to the end point, and finally it'll have a condition which basically will say when the loop should stop. Let's now explore what we refer to as a counter-controlled loop. Now, So far we've just looked at a very basic one where we're starting at 0 or 1 and then ending at a specific 1. And we're going up in increments of 1. Let's tweak this code slightly. And I'm just going to change that x equals x plus 1 to become 2. What's going to be the output? Well, let's try and predict it. Okay, well, we're definitely going to be still starting at 0. So the first thing we're going to print out is still going to be 0. So that first value is going to be the same. However, now I'm adding 2 to x. So the next value of x is going to be 2. Because 0 plus 2 is obviously 2. So instead of printing out the 1, it's going to print out the 2. It's then going to skip 3 and print out 4 because 2 plus 2 is obviously 4. So let's run the code. You can see it's now printing out 0, 2, 4. Now this is still a counter-controlled loop because it's still predictable. Okay, the key to a counter-controlled loop is not that it always starts at 0 and ends at 10, it's that we can predict how many times it's going to run. Now that number of times it's going to run is not the value in the condition. Okay, you can see here it says 5, but actually we only have 3 outputs. So actually we have a pattern, a number pattern. And that's the thing to look for. So is how many times will this number pattern run until the value is bigger than whatever's in the condition. Okay, so that's kind of the way to think about it. So let's change it again. So let's set this to be 4 and run it one more time. You can see now it only prints out 2 values. If I set that to be 1, print it out again, you can see I'll now have 1 and 5. So why have I got a different value this time? Well, I start at the value of 1, print that 1 out, add 4 to it, becomes 5. Well, x is less than or equal to 5, so it's going to print that one out. If I change this to 7 and run it again, I get the exact same output because x is 5 after the first loop of this. Add another 4 to it. Well, 5 plus 4 is 9. 9 is not less than or equal to 7, therefore it won't run a third time. So we can change these values as much we want to. So I can start at a big value and end at an even bigger value. And maybe I can go up in 25s or something like that. Let's run it. And there you go. So I'm not constrained by the starting value, the end value, and the increment. The only real constraint I have to worry about is, first of all, can I predict how many times this is going to run? Is the change of the variable x going to eventually get me to stop this loop? Okay, so for example, if I subtracted 25 there, I'd get an infinite loop, wouldn't I? Because I'd keep subtracting 25 from the number, so the number will keep getting smaller, so it never will get bigger than 100. So let's explore this again, but this time I'm going to start at 10, this time I'm going to end at 0. And instead of adding 25, I'm going to subtract 1. So now I'm going to go backwards. Now, when you are descending, we actually have to consider the condition. Okay. Now in this case, to change condition, I simply would swap the sign over. If I run that, you can see I go from 10 to 1. Now, again, I'm not constrained by -1. I can change that to -2. I can maybe stop it when I get to 4, and so on and so forth. So again, I can change the starting values, the end values, and the increment as much as I want to, as long as it fits the pattern that I want to do. Okay, that is the key. That's the most important part about this. So to summarize, with a counter-controlled loop, I must have a variable. That is the most important thing. That's the one thing that cannot change. The second thing is I need to give it a starting value. Now that starting value could be anything. Okay, I then need a kind of end value, and I need to make sure that my condition is correct. So if the condition, if the starting value is bigger than the end condition, then I'm going to use the greater than symbol. If the variable here is smaller than this one, then I'm going to swap the sign over. Okay, that is really important. Also, I need to really consider this. If I keep subtracting 2 from my starting value, will it eventually make this false. Okay, well in this case no it won't, because if I keep subtracting 2 from 1 I'm going to keep getting smaller and smaller numbers, which means it's always going to be less than 4, so I can do that. To debug these kind of programs, just simply ask yourself the question, what is the number pattern it is generating? Okay, and you can predict that, because what I'm really doing is I'm starting at value 1, then adding 2 to it, well then adding 2 again, then adding 2 again. Yeah, so you get the idea. So if I run that, you'll see I get that number pattern. When that number pattern gets to a point where it's bigger than my end condition, then obviously the loop will stop, so then I can stop as well. So as long as I get to that end point using my number pattern, then it will work, the code is correct. So it's now your chance to actually do some coding, so it's a good time to stop and actually practice. So what I want you to do is write a program which will display the 12 times table. Okay, so you need to consider the following things. So first of all, you need to consider what the starting point is. So where is it starting? Big tip is look at that numbers, because when you have a variable, the word vary means it's going to change. So the only two things that change in this is the actual answer and the thing I'm timesing 12 by. So 1 times 12, 2 times 12. Big hint, this here is what I want to be able to change. So that is going to be my starting point. My end point, well, think about when the 12 times table tends to end. Think back to primary school. When did you stop your 12 times table? That's where your program should end. And how's it going to change? Well, what's the pattern between these numbers? Okay, how am I getting from 1 to 2, 2 to 3, so forth? I mean, I'm hoping it's obvious, but it's worth pointing out. The last thing is I want you to display the answer so it looks a bit like what's on the screen right now, like I'm circling it. So this is slightly harder. Think about well, how I'm going to structure it. What stays the same in this sentence? What's changing? And how might you structure that? Okay, that's probably, if you're going to get stuck on one part, it's probably going to be that part. After this, pause it, have a go. I've got a model answer coming up in a second. So let's look at the model answer for doing 12 times tables. So the starting point is going to be 1. Now, some people, when they tackle this problem, they might think, well, I'm doing 12 times tables, so my starting point must be 12. Okay, so my variable is going to be 12. However, if you think about it, 12 is the one number that never changes. Okay, so it's 1 times 12 is 12. 2 times 12 is 24. And you notice that it's like the 12 is the same because it's a 12 time table, so 12 is always going to be the same. So that's not my changing, that's not my variable. Okay, so the thing that changes is the thing I'm timesing 12 by. So 1 times 12, 2 times 12, 3 times 12. So it's that. So when does it end? Well, normally when we do our times table, we tend to end at 12. Okay, so 12 12s is where we'd end. I'll come back to how we display the answer in a moment, but I'm going to think about how it's going to change. Well, we do 1 times 12, 2 times 12, 3 times 12. So I'm adding 1 each time, aren't I? So x is going to be x plus 1. So how do I display the answer? Now, the simple way of starting is just simply, I can start off with the x, and you can see I'll get the numbers 1 to 12. Okay, so that's a good pattern. I might then times that number by 12. So now I'll get the answer of the 12 times table, but the response I wanted is it's something along the lines of 1 times 12 is 12, 2 times 12 is 24. So I'm going to start with my x as before. So that'll give me the 1 times, 2 times, and then I'm going to put in the text 12. So I actually put the text in times 12 is. Okay, now let's run that and see what happens. You can see it says 1 times 12 is 12. 2 times 12 is 24. Why? Well, this x is giving me those numbers at the start. And that is just simply going up in ones. So 1, 2, 3 and all that sort of stuff. I then always want that text to be displayed. I never want that to change. So it makes sense to just simply put that into quotation marks. So that is not a variable part of this statement. Okay, so each time we run, the times 12 always stays the same. And then finally, the x times 12 is what will give me the answer, which is why that comes at the end. So that is the full model answer to this question. And obviously it wouldn't be a video without a little challenge task. Now, to be honest with you, this challenge task, I think is dead easy. If you've got this, this is a dead easy task. The only reason I'm throwing it in there is because you have to think a little bit before having to go at it. So I want you to write a program which display odd numbers between 1 and 50, okay? There's an easy way of doing this and there's a hard way of doing it. I want you to go for the easy way, obviously. So think about the starting value, think about the pattern of the numbers. So what are the odd number patterns? So the first odd number is 1, then it's 3. What's the pattern? How is the 1 and the 3 different? That's the secret to this solution. Then the code for this is dead easy. So pause it now, have a go. The model answer is on the last bit of this video. So here's the model answer. As I said, it was dead easy, as you probably noticed. So long and short of it, start at 1 because the first number I wanted is 1, then 3, and so on and so forth. It ends at 50, which is why it's there. Obviously you could change that because 50 is not an odd number, so you might end at 49, or get rid of this equal sign and put 50 there. It doesn't really matter as long as you get the right output. And the secret to this answer was here, we're adding 2 each time. Okay, that was the secret. So hopefully that was really easy. The next video I'm going to delve into a bit more detail on how to actually put useful things inside our counter controlled loops. See you next time.